Welcome to PreMath. In this video, we have got this green shaded triangle CEF and this white shaded quadrilateral BAEF, fully confined in a big triangle ABC, as you can see in this given diagram, such that this segment CE is 3x, this segment CF is 11 times x, and moreover this segment AE is 7x, whereas this segment BF is 9 times x. And furthermore, the area of this white quadrilateral has been given to us as 25 centimeter square. And now our task is to calculate the area of this green shaded triangle CEF. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. Let's focus on this green shaded triangle CEF, whose side lengths are 3x and 11x. And now let's focus on this bigger triangle ABC. And we can see its side length AC is going to be the sum of these two individual lengths, 3x and 7x. That is going to give us 10x. And likewise, this side length BC is going to be the sum of these two individual segment lengths, 11x and 9x. If we add them, that is going to give us 20x. And here's our next step. Let's assume that this angle ACB is theta. And here's our next step. Let's focus once again on this big triangle ABC. And now we are going to calculate the area of this triangle ABC. And now let's recall the area of a triangle formula. Area equals to a half times A times B times sine of angle C. As you can see in this given triangle, these A and B are our side lengths, whereas this angle C is the angle in between. So therefore, for this triangle ABC, our side lengths are 10x and 20x, and angle theta is in between them. So therefore, the area of this triangle ABC is going to be a half times our side 10x plus other side is 20 times x times sine of angle theta. And now we are going to simplify the right hand side. Let's take care of this 10x times 20x. That is going to give us 200x square. And likewise, we are going to combine a half times sine of theta as well. So therefore, we can write this right hand side as sine of theta divided by 2 times 200x square. And I'm going to label this as our equation number 1. And here's our next step. Let's focus now on this green shaded triangle CEF. And we are going to calculate the area of this triangle CEF as well. And now let's recall the area of a triangle formula once again. Area equals to a half times A times B times sine of angle C, as you can see in this diagram. And now we can see for this green triangle, these 3x and 11x are the side lengths, and this theta is the angle in between. So therefore, the area of this triangle CEF is going to be a half times our side length 3x times 11x times sine of angle theta. And now let's focus on this 3x and 11x. We are going to multiply them out. That is going to give us 33x square. And likewise, we are going to multiply out 1 divided by 2 and sine of theta. So therefore, that is going to give us sine of theta divided by 2 times 33 times x square. And I'm going to label this equation as our equation number 2. So thus we are ended up with these two equations, equation 1 and equation 2. And now in this next step, we are going to calculate the ratio of the area of these two triangles, the ratio of triangle CEF area and the area of triangle ABC. And here we figured out our triangle CEF area, whereas the area of the triangle ABC is this one. So therefore, I am going to fill in the blanks over here. So the area of triangle CEF from equation 2 is sine of theta divided by 2 times 33 times x square divided by the area of the triangle ABC from equation 1 is going to give us sine of theta divided by 2 times 200 x square. And now we can see sine theta divided by 2 and this sine theta divided by 2, they are gone. This x square and x square is gone as well. So therefore, after all the simplification, we are going to get 33 divided by 200. So therefore, we can see the ratio of these two triangles turns out to be 33 divided by 200. In other words, if this whole triangle area is 200, then the area of this green shaded triangle is going to be only 33. So therefore, we conclude the area of this white quadrilateral is going to be simply 200, the whole triangle ABC area, minus the green shaded triangle is 33. So that is going to give us 167. So therefore, the ratio of this green shaded triangle CEF and the white quadrilateral area is going to be equal to 33 divided by 167. And here's our final step. Now we are going to calculate the area of this green shaded triangle CEF. And now we can see the area of this white quadrilateral BAEF has been given to us as 25 centimeter square. And here's our required ratio. So therefore, this green shaded triangle area is going to be 33 divided by 167 times 25 centimeter square. And now if we multiply the right hand side, that is going to give us 825 divided by 167 centimeter square. So thus, after all the calculations and manipulations, the area of this green shaded triangle turns out to be 825 divided by 167 centimeter square. And that is going to be approximately equal to 4.94 centimeters square as well. And that's our final answer. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.